Good afternoon. My name is Tom Sawinski, and I work in the Office of Nuclear Energy's Office of Advanced Reactor Technologies. There I serve as the Program Manager for Fast Reactor Technologies. And today I'll be presenting on the Nuclear Energy University Program's Fy19 Rc-3 category, which focuses on liquid metal-cooled fast reactor technology, development and demonstration to support deployment. This is slightly different than previous years in this scope. We're not looking generally for a specific area related to fast reactors, but instead we're broadening it to enhance innovative technologies to reduce the capital and operating costs associated with advanced fast reactors. I'm going to begin my presentation with a brief overview of the DOE's Fast Reactor Technologies program, followed by a discussion of some of the industry needs identified for fast reactors. I'll then show how those correlate into the development of this year's scope and relevant areas and examples as suggested areas for your scope developments. So to begin, I'd like to talk about the Advanced Reactor Technologies Fast Reactor Program. We have an overall strategy to create sustained infrastructure and to perform targeted research to enable commercial development of fast reactor technology in the United States. To support commercial deployment of fast reactor technologies, our program looks to address two main recurring challenges. The first is to reduce capital costs and investments in fast reactors to make them economically viable in the energy markets. And next is to develop a pathway for licensing for non-light water reactors. To address these challenges, the fast reactor program focuses on three key areas. First is research, development, and demonstration of innovative cost reduction and performance enhancing technologies, which is primarily a focus of this year's NEAP call. Next is clarifying fast reactor licensing criteria, developing science-based approaches for demonstrating regulatory compliance. This includes engaging with the Nuclear Regulatory Commission and resolving key issues for advanced non-light water reactors. And finally, we're working on developing, sustaining a flexible domestic infrastructure and knowledge base to support this research, development, and demonstration mission of fast reactor. Next, I'd just like to describe some of the key research and development areas underway within the DOE's Fast Reactor program. Within the area of cost reduction research and development, one of our primary items has been the development of the Mechanisms Engineering Test Loop facility at Argonne National Laboratory. This is a prototypical sodium environment that can be used for component testing and also for thermohydraulic studies of sodium at prototypic conditions for a fast reactor. We're also exploring supercritical carbon dioxide and sodium interactions for potential use of supercritical carbon dioxide systems in sodium-cooled fast reactors. We're also looking at advanced materials development to support a variety of fast reactor technologies. In terms of key regulatory R&D, we're looking at fast reactor knowledge preservation and validation. This includes areas such as legacy fuel data and operating experience from the DOE's experience with the Fast Flux Test Facility and the Experimental Breeder Reactor 2. Also looking at enhancing safety analysis tools and techniques for fast reactors, support licensing case and transient analysis. We're also looking at advanced modeling and simulation to support design and optimization of design for fast reactors, and as stated, historical fuel data qualification. And relevant to this year's call, we look at collaborative efforts, both internationally, university, and industry collaborations. Related to industry collaborations, a majority of the scope within the DOE program is heavily influenced by the technology needs of the Fast Reactor Industry Working Group. This is a standalone industry-led working group that has been in existence since July of 2016. As you can see on the slide, there is a variety of technologies associated with this fast reactor group, from sodium fast reactors to lead fast reactors to gas-cooled fast reactors, molten chloride fast reactors. And their needs have generally been broad in scope, and they usually identify R&D that can be accomplished through DOE R&D programs. In February 2017, they submitted to DOE a formal list of R&D needs, and they reaffirmed this need in January 2018. So the next slide gives just a large overview of the areas that they have suggested, and then I will go into the specific areas that correlate with this year's scope. So in terms of priority R&D areas, the working group identified the need for a fast test reactor, the need for managing legacy data for fast reactors based on the decades of experience DOE has had operating fast reactors. Next is looking at fuels, expanding fuel fabrication capabilities, fabrication methods, supporting access pathways to high-assay LEU. And then modeling and simulation. This includes code validation and quality assurance for fuels and materials performance, refining nuclear data to support new designs and analyses, and separate and integral tests and effect. So specifically within their needs, they have specific areas that are relevant to this year's scope. The working group suggested supporting ongoing flexible liquid metal component testing capabilities. This enables the testing of many components that may be associated with advanced non-light water reactors and specifically fast reactor designs. Next, they looked at optimizing opaque fluid management techniques. This can be in-service inspection and online monitoring for various coolants for fast reactors. Developing testing facilities, including high-temperature corrosion testing loops to support lead-based technologies. Optimizing and performing validation work on innovative heat exchangers for use in advanced energy conversion systems supporting sodium and lead technologies. And from an analytical side, reducing uncertainties in both fast reactor design codes and safety performance codes. With a general idea of DOE's programs and the strong support from industry, I now would like to go in detail of this year's scope. So this scope is seeking proposals to develop and demonstrate innovative technology options for liquid metal, both sodium or lead-cooled fast reactors, to support U.S. nuclear industry advanced reactor concepts. I'd like to specifically point out that we are looking to enhance existing technologies or utilizing technologies already available that can be utilized for advanced fast reactors to support commercial concepts. We are not necessarily looking for new innovative reactor concepts within the scope of this call. We are looking to focus on technologies or analytical and experimental capabilities to validate these technologies for potential deployment in the marketplace. As I stated, we're focusing on experimental analytical work that can offer potentially significant benefits to reducing reactor capital or operating costs. And I provided several examples, which I'll go through in a moment. And these, I want to emphasize, are examples of key areas. Now, though the proposals are not limited to these example work areas, the applicant should indicate in their proposal how their work will support current DOE, national laboratory, and/or U.S. nuclear industry liquid metal cooled fast reactor deployment and commercialization R&D initiatives. So I'll just go back one. So for examples, we have sensors and prognostic techniques for survival and advanced liquid metal cooled reactor environments, specifically in the areas of under sodium viewing as well, that are able, and also other areas that are used to detect degradation early within the primary vessel and can be embedded on structures or materials to enable structural health monitoring. Also looking at the development application of uncertainty propagation analyses. This can look at either safety analyses for fast reactors or operational considerations such as fuel burnup to optimize core design and potentially reduce costs. Also looking for development of test articles for the Mechanisms Engineering Test Facility at Argonne National Laboratory. These test articles can be used to either demonstrate innovative subcomponents such as sensors, seals, or other mechanisms for fast reactors, or to validate key fast reactor behaviors such as thermal striping under prototypic conditions. Also looking at detailed analytical performance studies for compact heat exchangers such as microchannel configurations, specifically for either lead or sodium cooled fast reactors, and also to support lead or lead business testing capabilities and test articles that would support lead fast reactor development and demonstration. One final item I'd like to note is this year's work scope may be supported by the UK's Engineering and Physical Sciences Research Council. This allows applicants to work with UK contributors, and US funded institutions will be funded by NEOP, and UK contributions will be funded by the EPSRC. With that, that concludes my presentation. I now open it up for your comments or questions.
Okay, thank you, Tom. We'll take questions over the next few minutes. We have until 3 p.m. Eastern time to take questions. So please use the question pane in the GoToMeeting application to submit those in writing. Tom, first question: should the supporting work scope have ongoing flexible liquid metal component testing capabilities, including molten salts?
No, this one is primarily looking at either lead or sodium coolants for this particular call.
The second question is also related to MSRs. So
understood. Right, that is outside the scope of this particular call. There are other MSR scopes.
Okay, we'll hang on for the next few minutes. Please submit your questions now. So the question is, the comment here, the question is about heat exchangers. Are heat exchangers of interest? He said MSR and liquid metal heat exchangers are very similar. So I wanted you to comment on heat exchangers as applicable.
Right, so the heat exchanger work is predominantly going to be focused once again on lead or sodium coolants. If the applicant can make a case for how those would be applicable, work done on molten salt related items, but they would have to make that applicable to a lead or a sodium type heat exchanger as well. So if they can make the correlation and show that there is an industry need for such that in the fast reactor realm, that could be considered.
Can we develop sample environments for material testing?
Yes, that would be within the scope of this particular item. If you can show how that would support those particular technologies, yes.
You mentioned partnering with UK entities. What was the name of that organization again?
It was the Engineering and Physical Sciences Research Council.
And the follow-up question here is, can you provide more details on this? Well, the information that we currently have is that they'll be participating in the 5 work scopes that were mentioned in the overview this morning. They'll be mentioned by each of the program managers here. We don't have specifics on what the UK response will be, but we wanted to let you know that those work scopes are eligible. So if you do have UK contacts, then that's an opportunity that's going to be presented in this work scope and several others. The PIs from the UK have also been invited to view this webinar, so they may be listening in. If that's the case, then you can reach out. We are not a matchmaker in any way, so we won't match you up with specific UK researchers. That will be your responsibility. For RC3, how does this scope differ from the one proposed for the IRP NEAMS 1 scope, if you're familiar with that scope?
I am not familiar with that scope. I would need more specifics on
that presentation is tomorrow. I'd encourage you to listen in. That is a scope that has not been, the text of that scope has not been released yet, okay, and will be released with the final FOA, but there'll be more details. There'll be more details there. I believe it's more computationally focused to support the experimental program.
Understand. Right, then feel free to email that question along to me.
Yeah. So what's being said in the room is, if you do have questions once you see that presentation tomorrow, to email Tom, or you can email one of the NUP staff directly, and we'll relay those messages to the individuals involved. What is the desired or expected scale of microchannel heat exchangers to be analyzed or tested?
I don't necessarily have those technical details. That would not be one that would be beneficial if they emailed me and I can get them in touch with the right technical leads to see what scale we are looking at this time.
Can you provide more details about your expectations for sensor R&D?
Right. So for the sensor R&D, you'll read specifically within the work scope when you see the FOA come out. It's very specifically looking at opaque management and prognostics. We're not necessarily trying to overlap with other scopes that will be more general in scope. There's work that's been done on under sodium viewing and other sensors, such as thermal acoustic sensors as well, and work on that is what we'd be predominantly looking at specifically within the scope of the fast reactor program. And that's another, we can give more follow-up information on that as well. But the work scope as written in the FOA gives more detail to that.
Okay, there's another UK question, so
Sure.
I'll read it
Okay.
and I'll answer that question as well. Is there coordination with a parallel UK FOA, or shall potential PIs need to search and index the funded UK researchers? From our experience in the past, there is a parallel UK funding solicitation that comes out. That, to my understanding, is not yet available. So as the second part of that question, yes, you should contact UK researchers based on whatever methods you've done that in the past. Like I said, we don't match make, and so it's up to you to make contact with those individuals. Where can we find the list made by the Fast Reactor Working Group on their needs?
And there needs, if you look on the presentation, I have the general listing of areas that they have already stated. I would have to talk with the industry working group to see about making that publicly available in terms of all the details. But the areas that were relevant to the scope, I provided the detailed language that the needs that they had stated.
Are you still interested in fission products and liquid metals?
We currently have work ongoing with that right now. So I generally wouldn't see that within this particular scope. We're looking more for technology development or enhancement of analysis techniques for either safety analysis or core performance, whereas that is more related to mechanistic source term, and that's work more in the regulatory item of previous years, so not at this particular time.
Can you elaborate on uncertainty propagation analysis techniques?
With that, we do have it generally broadly open. It would be worth the person interested in that proposal to look at some of the work that's been done already within the fast reactor program. But what I do know is we are focusing on either looking at improving safety analysis techniques and reducing uncertainty propagation, or core performance in terms of items such as burn up or core design. Basically, how that, and then the applicant should show how that correlates to potential cost savings or safety enhancements that may reduce operating costs or capital costs.
Are heat exchangers required to be microchannel, or can they be larger channel but still more compact than conventional shell and tube heat exchangers?
Right, so that can be opened as well. Like I said, these were just examples that we had. The key is to be able to correlate that with a either a commercial design or design that may be near-term deployment, or how that technology could optimize heat exchanger development to support near-term deployment.
Do you have any understanding at this point about how many cooperative agreements would be recommended for funding in this work scope?
At this time, I don't have those numbers off the top of my head. I'll have to see where we get. So. Right, that's it.
And as a general comment, we don't have a finalized budget, which means
Correct.
Question about how many awards will be funded in each area will be unknown to the program managers and to the NUP staff here. Okay, Tom, thanks for taking those questions. We will return in about 10 minutes to for our next work scope. Which will be on high temperature gas reactor simulations and fluoride salt cold high temperature reactors. That presentation will take place at 3:30 p.m. Eastern time. So excuse me, that will be about 45 minutes from now. Please tune in then. Thank you.